June 6, 1944, somewhere near Rouen, France, the metallic shimmer of a damaged P-51 Mustang descended through scattered clouds, its Packard Merlin engine trailing a faint ribbon of smoke. Lieutenant Thomas Fraser of the 334th Fighter Squadron, 4th Fighter Group, had lost his bearings amid the chaos above the Normandy beaches. His aircraft, bearing the squadron code QPG and nicknamed Jerry, struck the French countryside hard. Fraser survived the crash landing and would spend the remainder of the war as a prisoner. His aircraft, serial number 43 to 24825, AP-51B 15, NA model, was about to begin a journey that would deeply unsettle some of the Luftwaffe's most seasoned test pilots. The Mustang lay largely intact in that French field and was soon recovered by German salvage teams, who had perfected the systematic art of retrieving downed Allied aircraft across occupied Europe. Within weeks, this particular machine was transported to Rechlin, the Luftwaffe's principal testing ground roughly 100 kilometers northwest of Berlin in Mecklenburg, where it was restored using parts salvaged from other wrecks scattered throughout German-held territory. The aircraft emerged wearing German markings, its fuselage bearing the Luftwaffe code T9+HK, with its tail and undersides painted bright RLM-04 yellow for easy identification by friendly pilots who might otherwise mistake it for an enemy fighter. The propeller spinner was painted yellow, and a red band encircled the engine cowling. Following standard Luftwaffe identification protocols for captured aircraft, this Mustang was destined for one of the Luftwaffe's most unusual and specialized formations, the Wanderzirkus Rosarius. There, it would force German fighter pilots to confront an uncomfortable truth about American engineering, industrial prowess, and their own increasingly hopeless tactical position in the collapsing air war over Europe. The story of how captured enemy aircraft became instruments of revelation for the Luftwaffe begins not with Fraser's forced landing on D-Day, but with the intensifying air campaign over Europe and the desperate need for reliable, systematic intelligence on Allied aircraft performance beyond fragmented combat reports. By mid-1943, the Luftwaffe faced a strategic crisis threatening to overwhelm German air defenses despite the exceptional skill and courage of its pilots and ongoing development of advanced designs. American bomber formations were penetrating deeper into the Reich each month, shielded by fighters whose full capabilities remained only partially understood by German commanders forced to make operational decisions on incomplete data. Reports from frontline pilots offered conflicting and often chaotic descriptions, reflecting the confusion of combat rather than controlled analysis under repeatable conditions. Hauptmann Theodor Rosarius, a seasoned Luftwaffe officer, recognized that fighter units needed more than scattered accounts to effectively counter Allied aircraft. They required direct access to captured machines, opportunities to fly, test, and analyze them under structured conditions, to uncover true strengths and weaknesses through first-hand experience. The idea was not new. Both sides had tested captured aircraft, but Rosarius would systematize the process in a way that greatly enhanced its tactical value. In 1943, under orders from General der Jagdflieger Adolf Galland, Rosarius established what became known as the Wanderzirkus Rosarius, officially designated the second Staffel of the Versuchsverband Oberkommando der Luftwaffe, the Luftwaffe High Command's Trials and Research Unit. This elite detachment received all reparable Allied aircraft recovered by German salvage teams from crash sites across occupied Europe, from France and Italy to the Eastern Front. Its mission extended well beyond static ground testing. Rosarius organized traveling demonstrations where captured aircraft visited operational Luftwaffe bases throughout Germany and occupied territories. Frontline pilots could inspect the aircraft closely, observe demonstration flights, and in select cases, engage in mock dogfights against them. The program addressed a critical training deficiency that worsened as the war dragged on and pilot attrition soared. German fighter pilots trained almost exclusively against their own aircraft, developing tactics suited for fighting adversaries who flew in similar ways, using comparable aircraft, and following familiar doctrines. This created a dangerous blind spot when confronting Allied pilots flying machines with markedly different characteristics, especially in range, high-altitude performance, and sustained speed, and employing tactics that capitalized on those advantages. By 1944, the recovery of Allied aircraft had become a highly organized process. Specialized German salvage battalions operated across occupied Europe with impressive efficiency, securing crash sites, assessing damage, and transporting reparable wrecks to centralized depots before advancing Allied forces could reclaim them. The structure reflected characteristic German thoroughness even as resources dwindled. Given the sheer scale of Allied air operations, recoveries were inevitable. With thousands of sorties flown monthly by U.S. and British forces, mechanical failures, combat damage, navigation errors, fuel shortages, and weather incidents led to frequent forced landings within German-held territory. Many aircraft were not destroyed outright. Some pilots, realizing their situation was hopeless, executed controlled crash landings that left their machines mostly intact and reparable. Fraser's P-51B Mustang NA fell into this category. Damaged during intense D-Day fighter sweeps, it came down in German-controlled territory. Recovery teams arrived within hours, following established procedures to inspect the wreck. They found that, despite battle and impact damage, the airframe was intact enough for restoration. The Mustang was carefully loaded onto a transport and sent to Rechlin, where experienced technicians and engineers began the process of returning it to flight condition. Rechlin, officially designated the Luftwaffe's central test facility on February 26, 1936, had long served as the primary center for evaluating new German aircraft and conducting tests on captured enemy types. Its workshops were well equipped, its runways designed for control trials, and its technicians highly skilled at reverse engineering and repairing foreign aircraft despite lacking manuals, factory drawings, or genuine spare parts. Restoring Fraser's Mustang demanded creativity and technical skill that reflected both German competence and the growing scarcity of materials. Mechanics cannibalized parts from other wrecked P-51s to assemble one operational aircraft from several damaged ones. The Packard V1650-3 Merlin engine, a licensed version of the Rolls-Royce Merlin 63 with a two-stage, two-speed supercharger producing 1,490 horsepower at 13,750 feet using 61 inches of boost, was overhauled with replacement parts sourced from multiple locations. This engine was a technological marvel, offering far greater high-altitude power than single-stage units through its complex intercooled supercharger design. The aircraft's .50 caliber Browning M2 machine guns, 2 per wing in the P-51B layout, were removed and replaced with ballast weights to preserve balance and center of gravity. German regulations strictly forbade arming captured aircraft used for testing or demonstration, both for safety and to prevent their use against German forces if lost or captured. Control surfaces were checked for structural soundness and proper movement. Hydraulic systems underwent pressure testing, and fuel tanks were examined for cracks or leaks that could prove disastrous in flight. The razorback canopy typical of the P-51B was carefully repaired, though German pilots would later remark that its framing restricted rearward vision compared to the bubble canopy introduced on the later P-51D model. After weeks of painstaking work with limited tools and improvised methods, the Mustang was finally declared flight-ready. German test pilots approached their first encounters with captured American fighters with professional curiosity mixed with deep skepticism, the result of years of propaganda portraying U.S. aircraft as crude, mass-produced machines built for quantity over quality. Official messaging had long claimed that American engineering prioritized simplicity and output rather than sophistication and refinement. These assumptions collapsed the moment experienced German pilots sat in the Mustang's cockpit and experienced what American designers had truly achieved through careful engineering and attention to operational detail. The cockpit layout immediately impressed them, particularly those accustomed to the cramped Messerschmitt Bf 109 or even the roomier Focke-Wulf Fw 190. The Mustang's controls were logically arranged, easily reached, and designed to minimize pilot workload, allowing focus on combat rather than aircraft management. Instruments were clear, well-grouped, and sensibly organized by function, reflecting a human-centered design philosophy that prioritized pilot efficiency and effectiveness. The seat provided noticeably better comfort than German fighters, an important consideration during multi-hour missions, where pilot fatigue could significantly impact performance and decision-making. Visibility, even in the earlier Razorback configuration with its framed canopy, exceeded what Bf 109 pilots experienced with their heavily framed canopies, restricted sightlines, and particularly poor rearward visibility. That left German pilots vulnerable to attacks from behind. But the true revelation came when German test pilots advanced the throttle and felt the Packard 516-503 Merlin engine respond with smooth, progressive power delivery. The power built steadily and predictably as the Mustang accelerated down Rechlin's runway, the four-bladed Hamilton standard propeller biting efficiently into the air. The takeoff roll was noticeably shorter than expected for an aircraft of the P-51's weight and size. Clear testimony to the engine's substantial power output and the airframe's efficient aerodynamic design that minimized drag throughout the speed range. Once airborne, the Mustang demonstrated handling characteristics that fundamentally challenged everything German pilots thought they understood about American aircraft design philosophy and engineering capabilities. The flight controls were beautifully harmonized with aileron, elevator, and rudder forces perfectly balanced across the entire speed range from approach speeds to maximum velocity. Control forces increased predictably with speed, providing good feedback without becoming excessively heavy, and decreased smoothly at lower speeds without becoming overly sensitive or twitchy. The Mustang responded crisply and predictably to control inputs without displaying the oversensitivity or nervous handling characteristics that plagued some fighters. Roll rate exceeded that of the Bf-109 significantly and approached the exceptional roll performance of the Fw-19, allowing rapid changes in flight direction that were critical for both offensive and defensive maneuvering in combat. The aircraft could be thrown aggressively into various maneuvers without displaying any troubling tendency toward departure from controlled flight, spin entry, or other dangerous characteristics that could prove fatal in combat situations. German test pilots systematically evaluated the Mustang's performance envelope through carefully planned test flights, pushing the aircraft through standardized maneuvers specifically designed to reveal its strengths, limitations, and any hidden dangerous characteristics. Climb performance impressed them considerably and generated significant concern about tactical implications. The P-51B could maintain excellent climb rates to altitudes well exceeding 30,000 feet, where the two-stage supercharged Merlin engine continued producing substantial power, even as the progressively thinner air at altitude severely degraded performance in German fighters equipped with single-stage superchargers. High-altitude performance particularly concerned German pilots and tactical planners because American bomber formations typically operated between 25,000 and 30,000 feet, where the air was thin and cold, but defensive fire from bombers remained effective against fighters that had to slow down to attack. German fighters equipped with single-stage superchargers struggled increasingly to intercept effectively at these altitudes, their engines gasping for sufficient air, while the Mustang's sophisticated two-stage Merlin continued delivering robust, reliable power. The revelation proved sobering to pilots and commanders who understood the implications. The Mustang could not only escort bombers to these altitudes, but could fight there effectively, maintaining speed advantage and maneuverability, while German interceptors labored with reduced power, slower speeds, and degraded handling as their engines fought against the thin atmosphere. Speed trials conducted under controlled conditions at various altitudes confirmed the Mustang's clear superiority in this critical performance category. The P-51B could achieve approximately 440 miles per hour at optimal altitude with the engine running at military power settings, significantly faster than the Messerschmitt Bf-109G's approximately 386 miles per hour, and the Focke-Wulf Fw-90A's approximately 48 miles per hour when measured under comparable conditions. This substantial speed advantage proved tactically decisive in combat because it fundamentally allowed Mustang pilots to dictate engagement terms according to their advantage. American pilots could choose when to engage, pursuing fleeing German fighters when the tactical situation favored attack. Equally important, they could choose to disengage from unfavorable encounters, accelerating away from German fighters that lacked sufficient speed to pursue or force continued combat. German pilots discovered they could not force combat on a Mustang whose pilot recognized an unfavorable situation and chose to avoid engagement, fundamentally undermining German tactical flexibility. The wing design of the P-51, based on Nocca laminar-flow airfoil sections, gave the Mustang its distinctive appearance and delivered exceptional aerodynamic efficiency, though German engineers noted that achieving true laminar-flow in operational conditions remained elusive due to manufacturing tolerances, surface imperfections, rivets, paint, and operational wear. Nonetheless, the P-51's wing generated substantial lift with minimal drag compared to conventional airfoils, significantly contributing to the aircraft's remarkable range and fuel efficiency. This wing design maintained its effectiveness across a remarkably broad speed range, from relatively low speed handling during landing approaches through high-speed performance during combat maneuvering, providing consistent, predictable handling, characteristics that reduced pilot workload and enhanced combat effectiveness. Dive performance revealed yet another area where the Mustang demonstrated clear superiority over German fighters. The aircraft could dive at very high speeds without encountering the severe control stiffening and reduced control effectiveness that plagued many fighters when approaching or exceeding their maximum design speeds. Pilots could pull out of steep high-speed dives without requiring excessive physical effort or fighting against locked controls, and the airframe remained stable throughout the maneuver without tendency toward flutter, buffeting, or structural failure. German test pilots noted this capability with particular interest and concern, because diving attacks represented a primary German tactical doctrine for engaging bomber formations and escorting fighters, attacking from altitude to build speed and energy before pulling back up. The Mustang's ability to follow German fighters through high-speed dives and maintain full control authority throughout the maneuver eliminated a key German tactical advantage. Turn performance presented a more complex and nuanced picture that required careful analysis. The Mustang could not match the sustained turn rate of the Bf 109 in level flight at moderate speeds, particularly as the Bf 109 benefited from leading-edge slats that automatically deployed during high angle of attack maneuvering and delayed wing stall during tight turns. In sustained slow-speed turning fights at medium altitudes, the lighter and more compact Bf 109 held a measurable advantage in turn radius and turn rate. However, German pilots discovered through systematic testing and mock combat that the Mustang's clear superiority in speed and climb rate allowed skilled pilots to avoid sustained turning engagements entirely and instead fight using energy tactics. The Mustang excelled at converting speed to altitude and altitude back to speed efficiently, enabling pilots to maintain energy state throughout combat maneuvering. This capability allowed Mustang pilots to engage when advantageous and disengage when threatened, forcing combat on their terms rather than accepting the enemy's preferred combat geometry. The Mustang's structural strength and robust construction impressed German engineers who examined the airframe in systematic detail at both Rechlin and at Göttingen, where more detailed technical evaluations occurred. The aircraft was substantially built with significant safety margins engineered into critical structural components throughout the airframe. This robust construction philosophy contrasted markedly with German design approaches that often pushed structural limits to absolute minimums in pursuit of weight reduction and maximum performance. The P-51 could sustain significant battle damage that would have destroyed lighter German aircraft and still successfully returned to base, a capability that directly translated into pilot survival rates and aircraft availability for subsequent missions. American engineering philosophy clearly emphasized survivability and maintainability, accepting somewhat higher empty weight in exchange for durability that kept aircraft and pilots in combat longer. Range capabilities astounded German pilots accustomed to the severely limited endurance of their own fighters, which rarely exceeded 90 minutes of total flight time, including combat. The P-51B carried substantially more internal fuel than the Bf 109 or Fw 190, and the aerodynamically efficient wing design translated this fuel capacity into truly extraordinary range that seemed almost incredible to German pilots. With external drop tanks attached under the wings, the Mustang could fly missions exceeding 8 hours duration, covering operational distances that seemed nearly impossible to German pilots, whose combat radius barely exceeded 200 m under optimal conditions. This massive range advantage fundamentally transformed bomber escort operations in ways that proved strategically decisive. Early in the war, German fighters could simply wait until shorter-range Allied escorts reached their fuel limits and turned back toward their bases, then attack unprotected bombers during the most dangerous portions of their missions deep in German territory. The Mustang completely eliminated this tactical window. American escorts could now accompany bombers throughout entire missions deep into Germany and back to England, preventing German fighters from ever finding truly vulnerable targets. The strategic implications were profound and deeply troubling to Luftwaffe commanders who understood that German fighters now had to fight their way through escorts to reach bombers, dramatically increasing the risk German pilots faced on every interception sortie. German pilots who flew captured Mustangs in both test flights and mock combat consistently reported being profoundly impressed by the aircraft's harmonized handling characteristics and overall ease of operation. The flight controls required neither excessive physical strength nor excessively delicate touch, striking an ideal balance that allowed pilots to fly aggressively and precisely without fear of over-controlling the aircraft or inadvertently losing control during violent maneuvering. This forgiving ease of handling meant that average pilots could extract good performance from the Mustang under most conditions, while exceptional pilots could achieve remarkable results by fully exploiting the aircraft's capabilities. Maintenance accessibility surprised German ground crews familiar with the sometimes extraordinarily difficult servicing requirements of Bf 109 and Fw 190s, particularly when working under field conditions with limited equipment. The Mustang's engine cowling opened in multiple sections that provided excellent access to the Merlin engine and its accessories, fuel system, hydraulic components, and electrical systems. Panels throughout the airframe could be quickly removed to reach internal systems for inspection, adjustment, or repair. The overall design clearly reflected American emphasis on rapid maintenance turnaround and high operational availability. Recognizing that aircraft sitting on the ground awaiting repairs contributed nothing to combat effectiveness, regardless of their theoretical performance capabilities. The Wonders Rosarius took the captured and repaired Mustang-coded T9 plus HK on an extensive tour to operational Luftwaffe fighter bases across Germany during late 1944, visiting numerous locations where frontline fighter units were based. At each stop, the unit would establish temporary operations and set up comprehensive demonstrations, showing German pilots exactly what Allied aircraft could do in flight and teaching them specific tactics designed to counter Allied strengths while identifying and exploiting whatever weaknesses could be found. The demonstrations typically began with captured aircraft taxiing past assembled German pilots and ground personnel, creating surreal scenes as enemy aircraft bearing German markings and bright yellow identification paint moved among German fighters. Seeing these aircraft up close had substantial psychological impact, making the enemy tangible and real rather than abstract. Then came flight demonstrations where experienced German test pilots would fly the captured aircraft through carefully choreographed aerobatic routines and tactical maneuvers, demonstrating specific performance capabilities in ways that were far more effective than written reports or verbal briefings could ever be. For the Mustang demonstrations, test pilots would perform high-speed passes at low altitude to dramatically show the aircraft's significant speed advantage over German types. They would execute climbing maneuvers to altitudes exceeding 30,000 feet to display the remarkable climb performance and high-altitude capability enabled by the two-stage supercharged engine. They would demonstrate the P-51's excellent roll rate through a series of crisp aileron rolls that showed how quickly the aircraft could change direction. Mock dogfights against German fighters would illustrate both the Mustang strengths and the limited circumstances under which German fighters retained advantages. After the flying display concluded, pilots and ground personnel could approach the aircraft on the ground, examine it closely, inspect the cockpit layout and instrument panel, and ask detailed questions of the test pilots who had extensive experience flying the captured machine. These hands-on, educational sessions proved invaluable for demystifying enemy aircraft and providing concrete, tangible understanding of what German pilots faced in actual combat operations. The most valuable and impactful component of these base visits involved mock combat sessions where captured Allied fighters would engage German fighters in carefully controlled simulated combat under observation. Selected experienced German pilots would fly their own operational aircraft against the captured types, experiencing firsthand how Allied fighters handled in dynamic combat situations and learning what worked and what proved ineffective against specific Allied aircraft. One such demonstration took place at an airfield hosting Yagashata 1 during late 1944 as Allied bomber operations intensified and German losses mounted. The base commander had arranged for several of his most experienced pilots to fly mock engagements against the captured Mustang to gain practical knowledge they could pass on to squadron mates. The German test pilot flying the P-51 demonstrated tactics that American pilots typically employed in actual combat, using the Mustang's clear advantages in speed and climb performance to maintain energy throughout the engagement while avoiding situations where the Mustang's lesser turn performance became a significant disadvantage. German pilots flying Messerschmitt Bf 109GS and Focke-Wulf Fw 190 as attempted to engage the Mustang using standard Luftwaffe tactics that had proven effective against earlier Allied fighters. They quickly discovered the extreme difficulty of successfully engaging a Mustang whose pilot understood and properly utilized energy management techniques and the aircraft's performance advantages. When German pilots pursued aggressively, the Mustang would simply accelerate away, opening distance faster than they pursuing German fighters could close it. When German pilots attempted to climb to gain an advantageous position above the Mustang for a diving attack, the P-51 outclimbed them, reaching superior altitude first and reversing the tactical situation. When German pilots tried to force a sustained turning fight where the Bf 109's superior turn performance should have provided advantage, the Mustang pilot would refuse the engagement by extending away using superior speed, then reverse back into the engagement with renewed energy advantage when conditions favored the attack. The mock combat sessions proved sobering for German pilots who had believed or hoped that their aircraft and established tactics remained reasonably competitive with Allied fighters despite the deteriorating strategic situation. Directly observing and experiencing the Mustang's performance capabilities in dynamic combat maneuvering demonstrated clearly that American pilots flying P-51s possessed significant and fundamental tactical advantages, particularly at the high altitudes where bomber escort combat typically occurred. This pattern of revelation and gradually dawning realization repeated itself across numerous Luftwaffe bases where the Wunder Circus Rosarius conducted demonstrations throughout late 1944 and into 1945. German pilots received official assurances about the continuing superiority or at least competitive parity of their aircraft during pre-demonstration briefings. Then, experienced actual combat and flight demonstrations that directly contradicted those optimistic assessments. The captured aircraft demonstrations provided concrete, undeniable evidence that German fighters faced formidable opponents whose capabilities significantly exceeded what propaganda and official communications suggested. Walter de Hall, who commanded fighter units during 1944, later wrote about Wunder Circus Rosarius visits to his bases in his memoir. Though historians note his accounts must be treated cautiously due to documented reliability issues throughout his writing, he described how captured American fighters would arrive along with captured heavy bombers, creating unusual and somewhat surreal scenes where enemy aircraft parked peacefully alongside German machines while pilots examined them closely. Formation leaders received opportunities to fly captured aircraft in controlled mock combat, allowing them to understand Allied aircraft characteristics through direct personal experience rather than relying solely on second-hand reports and Official briefings. Dahl emphasized the substantial value of this training, noting that familiarity with enemy aircraft capabilities represented a factor not to be underestimated in aerial combat, where split-second decisions often determined survival. Following these demonstration sessions, flight leaders would conduct detailed training lectures with their squadron members, passing along specific recommendations and tactical insights based on their personal observations and direct experience flying captured Allied aircraft. This systematic knowledge transfer helped prepare German pilots for combat encounters with more realistic understanding of both Allied strengths and the increasingly limited circumstances under which German fighters retained exploitable advantages. The program achieved decidedly mixed results by late 1944 as Germany's strategic situation deteriorated across all fronts, while the demonstrations unquestionably provided valuable tactical intelligence and improved German pilot understanding of Allied aircraft capabilities. This knowledge could not overcome the fundamental and growing disadvantages German forces faced. The Luftwaffe suffered from chronic and worsening fuel shortages that severely limited flight training hours for new pilots, resulting in inadequately prepared pilots being sent into combat with minimal experience. Experienced pilots who understood, through hard-won combat experience, how to fight effectively against aircraft like the P-51 were increasingly rare, lost to relentless attrition during the brutal air combat of 1944 that saw German fighter pilot losses reach unsustainable levels. Aircraft production, while remaining surprisingly high despite intensive Allied strategic bombing of German industry, could not replace losses quickly enough to maintain force strength. Most critically, the training revelations from captured aircraft often served primarily to demoralize rather than inspire as pilots realized the full extent of their disadvantages. German pilots recognized with growing clarity that they flew inferior aircraft, or at minimum aircraft inferior in the most critical performance categories for the missions they were assigned. The P-51's speed superiority, exceptional range, and outstanding high-altitude capability could not be equaled by any German fighter then in active service. The technical insights gained from captured Mustangs went far beyond basic flight testing or combat trials. German engineers at both Rechlin and Göttingen carefully dismantled P-51 assemblies to study American production methods, material choices, and design philosophies in detail. They scrutinized the wing construction and airfoil geometry with meticulous precision, analyzing manufacturing techniques to uncover how American designers had achieved such remarkable aerodynamic efficiency. Particular attention was given to the Packard-built 1650-3 Merlin engine, whose complex two-stage, intercooled supercharger system provided outstanding performance at altitude. The fuel system drew equal curiosity as technicians sought to determine how U.S. engineers had obtained such impressive operational range. Hydraulic systems were evaluated for their dependability and ease of upkeep compared to their German equivalents. German specialists repeatedly noted the consistently excellent quality of materials throughout the airframe. America's access to premium aluminum alloys, specialized steels, and durable rubber compounds enabled designers to build structures that balanced strength, lightness, and efficient mass production. By 1944, German industry was crippled by growing material shortages, forced to employ inferior substitutes that often lacked the same strength, durability, or manufacturing precision. The examination of captured Mustangs revealed advanced industrial practices that made genuine mass production possible without greatly sacrificing quality control. U.S. factories built P-51s on highly refined assembly lines that maintained exceptional tolerances and uniform quality across tens of thousands of aircraft. In contrast, German production had become fragmented, spread among small, scattered workshops to escape Allied bombing, often relying on poorly trained or coerced labor, which reduced consistency, efficiency, and service reliability in the finished machines. The captured Mustang, designated T9+HK, served within the Wanderzirkus Rosarius until December 10, 1944, when both the aircraft and its pilot, Oberleutnant Lübschans, were lost. Records remain unclear whether it was destroyed in a flight mishap, an Allied air raid, or another wartime event. By that stage of its second career, the plane had toured much of Germany, visiting numerous Luftwaffe bases and offering first-hand experience to hundreds of German pilots who gained invaluable familiarity with Allied aircraft performance. Other captured Mustangs fulfilled comparable testing and demonstration duties. Surviving documentation and post-war analysis confirmed that at least 2 P-51s flew with the Wanderzirkus Rosarius during 1944 and early 1945, carrying Luftwaffe markings T9 plus CK and T9 plus HK. Some later accounts erroneously mention codes T9 plus FK and T9 plus PK, but research shows that T9 plus FK was actually a captured P-47D Thunderbolt, while T9 plus PK belonged to a seized Soviet Lavochkin La-5FN fighter. The T9 prefix itself was not officially linked to any Luftwaffe unit, suggesting it was an informal code reserved specifically for Rosarius-captured aircraft operations. One documented P-51B was flown at Neuruppin Airfield, roughly 60 kilometers northwest of Berlin, to train Hungarian pilots in tactics for engaging American Mustangs with their Focke-Wulf Fw 190s. This cooperation recognized the Mustang's growing threat and the need to share counter-tactics among Axis allies. Training emphasized exploiting the few remaining advantages, such as superior turning performance at low speed and altitude, while avoiding engagements that favored the Mustang's overwhelming strengths in speed, climb, and high-altitude fighting. The broader consequences of German pilots directly flying and studying superior American fighters extended well beyond immediate tactics. The Mustang stood as undeniable proof that U.S. industrial and technical capability equaled or even surpassed that of Germany, contradicting years of propaganda portraying American engineering as crude and unsophisticated. This realization eroded confidence and morale among Luftwaffe pilots, many of whom recognized they were fighting at an ever-increasing disadvantage no amount of skill, courage, or tactical ingenuity could offset. The Mustang's range, in particular, caused grave concern among German strategists. What had once seemed a manageable bomber offensive became unstoppable once long-range escorts could accompany Allied formations deep into the Reich. German interceptors could no longer wait for the escorts to turn back for lack of fuel. Every raid now featured continuous fighter protection, dramatically raising German losses. Production figures told the rest of the story. By late 1944, U.S. factories were turning out roughly 500 P-51s per month, a figure that peaked at 881 monthly by January 1945, more than double the total output of all German single-engine fighters combined. Each Mustang left the line equipped with dependable engines, precise instruments, and radios that functioned reliably, luxuries that late-war German fighters rarely enjoyed. American aircraft were maintained by trained ground crews with proper tools, manuals, and ample spare parts, while German squadrons struggled with shortages, substandard materials, and undertrained maintenance personnel. Differences in pilot preparation deepened the imbalance. American flyers typically logged 200 to 400 hours of comprehensive training, including combat tactics, instrument navigation, and formation flying under varied conditions. By contrast, severe fuel shortages and bombing disruptions had cut German training drastically. New Luftwaffe pilots often arrived at the front with barely 100 hours of total flight time and minimal combat practice. Inexperienced, undertrained airmen faced veteran Allied pilots in superior machines, a combination that led to catastrophic losses. By 1944-45, Luftwaffe attrition reached unsustainable levels as skilled veterans were killed faster than replacements could be trained. Many new pilots survived only a handful of missions before being shot down. The Luftwaffe was bleeding away its most irreplaceable resource, experienced aviators, at a pace that ensured inevitable defeat. The Wanderzirkus Rosarius demonstrations exposed these grim realities firsthand, showing German pilots precisely what awaited them in the skies long before they faced it in mortal combat. While this advanced preparation theoretically improved their chances of survival by providing realistic understanding of what they would face, it simultaneously made painfully clear the deteriorating situation German forces faced across all dimensions of the air war. Pilots who flew the captured Mustang or observed demonstration flights understood with uncomfortable clarity that they would confront opponents with significant and fundamental performance advantages in the specific areas that mattered most: speed, range, high altitude capability, and overall numbers. This knowledge, while possessing some tactical value, contributed substantially to the severe psychological pressure German pilots experienced during late 1944 and early 1945 as strategic reality became impossible to ignore. Some German test pilots who extensively flew captured P-51s through multiple test flights and mock combat engagements developed grudging professional respect for American engineering prowess and design philosophy despite their position as enemies. They recognized through direct experience that the Mustang represented a coherent, well-integrated design that intelligently prioritized the characteristics most valuable for its intended strategic mission of long-range bomber escort. The aircraft deliberately sacrificed some characteristics like sustained turn performance that might have been optimized for pure dog fighting in favor of speed, extraordinary range, and high-altitude performance that enabled it to escort bombers deep into Germany and fight effectively throughout the mission. This represented sound engineering judgment that selected appropriate design compromises to achieve clearly defined mission objectives rather than pursuing theoretical performance maxima that didn't serve actual operational requirements. The Mustang's ease of production also impressed German engineers who understood manufacturing challenges intimately through their own experiences. The aircraft's design facilitated true mass production through modular construction that allowed parallel manufacturing, standardized components that reduced complexity and training requirements, and design features that deliberately simplified assembly operations. American factories could produce Mustangs in large numbers while maintaining consistently high quality because the fundamental design itself accommodated production requirements from the beginning. Rather than treating manufacturing as an afterthought, German aircraft designs often prioritized absolute performance over manufacturability, resulting in aircraft that were difficult and time-consuming to produce even under optimal conditions, much less in the deteriorating circumstances of late-war Germany. The Packard 51650-3 Merlin engine that powered Frazier's P-51B and other early production Mustangs represented another critical area where American capabilities exceeded German achievements. The Packard Company successfully manufactured Rolls-Royce Merlin engines under license in the United States, producing many thousands of engines with remarkably consistent quality despite the complexity of the design. The sophisticated two-stage supercharger with intercooler enabled excellent and sustained high-altitude performance that German inline engines could not match, while the engine proved reliable and relatively maintainable under field conditions. German inline engines like the Daimler-Benz DB605 suffered from increasing quality problems during 1944 as severe material shortages forced the use of substitute materials and production dispersal to avoid bombing significantly reduced quality control effectiveness. The psychological impact on German pilots who thoroughly understood through direct experience the performance gap they faced cannot be overstated or dismissed as mere morale problems. These men had entered the war confident in their superior training, the capabilities of their aircraft, and the effectiveness of their tactical doctrines. By late 1944, extensive combat experience and direct exposure to captured Allied aircraft through programs like the Wunder Circus Rosarius had systematically eroded that confidence. They recognized with painful clarity that they fought opponents who possessed decisive advantages in aircraft performance, overwhelming numerical superiority, better logistic support, more thorough training, and superior intelligence. Flying combat missions under these conditions required extraordinary courage that bordered on fatalism and acceptance of likely death or severe injury. Former Luftwaffe pilot accounts and post-war interviews from this period frequently describe the hopeless feeling of watching American fighter formations appear on the horizon and knowing intellectually that those escorts could not be avoided through any tactical maneuver and could not be outrun by any German fighter in operational service. German pilots understood that engaging Mustangs at high altitude meant fighting at severe disadvantage in every performance category that mattered. Declining to engage meant allowing American bombers to strike targets unopposed, accelerating Germany's military and industrial collapse. Neither option offered acceptable outcomes from a professional military perspective. Yet these were the stark choices German fighter pilots faced daily during the final year of the war. As their strategic situation deteriorated beyond any possibility of reversal, the Wanderers Rosarius continued operating into early 1945, conducting demonstrations with various captured aircraft as long as aviation fuel remained available in sufficient quantities, and operational airfields could be maintained against Allied ground advances from both east and west. As Allied forces advanced progressively deeper into Germany from multiple directions, the unit's ability to travel safely to operational bases to conduct demonstrations diminished steadily. Eventually, the program necessarily ceased operations as the general collapse of German military organization overtook even specialized units like test and evaluation groups that had previously received priority for scarce resources. The ultimate fate of various captured P-51s operated by German forces remains unclear or unknown in several cases due to incomplete records and the chaos of Germany's final collapse. Some captured aircraft were certainly destroyed on the ground during Allied air raids against German airfields that intensified dramatically during 1945. Others may have been deliberately destroyed by retreating German forces to prevent their recapture by rapidly advancing Allied armies. A few possibly survived until war's end and were subsequently recovered by Allied forces advancing into Germany, though detailed records of such specific recoveries remain limited or lost. The knowledge gained from systematically testing captured Mustangs provided German pilots with valuable tactical intelligence about aircraft capabilities, optimal engagement parameters, and exploitable weaknesses. But this knowledge ultimately could not overcome the fundamental and overwhelming disadvantages the Luftwaffe faced by 1944. Understanding intellectually that the Mustang could outrun, outclimb, and dramatically outrange German fighters offered limited practical benefit when German pilots still had to engage these superior aircraft in defense of German territory under direct orders. The testing and demonstration program represented a sophisticated and systematic attempt to counter Allied advantages through tactical innovation and improved pilot knowledge. But tactics and knowledge alone could not compensate for inferior aircraft performance, severe numerical disadvantage, inadequate training due to fuel shortages, and chronic shortages of spare parts and experienced maintenance personnel. Lieutenant Thomas Fraser's P-51B 15NA, serial number 432-4825, had an extraordinary afterlife following his forced landing on D-Day. From a crashed fighter lying in a French field, it became an instrument of revelation for German pilots, concretely demonstrating American engineering capabilities and forcing acknowledgement of Allied air superiority that no amount of propaganda could overcome. The aircraft served this important educational role until its loss in December 1944, having traveled extensively across Germany and provided hands-on experience and sobering realistic assessment to hundreds of Luftwaffe personnel. The story of captured Mustangs in German service illustrates the sophisticated and professional approach the Luftwaffe took toward understanding enemy capabilities despite Germany's deteriorating strategic position. Rather than relying solely on fragmentary combat reports and intelligence assessments of uncertain reliability, German forces invested significant and scarce resources in recovering, repairing, and systematically flying captured Allied aircraft under controlled conditions. This systematic approach to tactical intelligence gathering represented best practices for military organizations seeking to understand opponent capabilities accurately, and it continued even as Germany's strategic situation became increasingly hopeless. The Wunderscurus Rosarius program demonstrated that even sophisticated intelligence gathering, professional competence, and systematic analysis could not overcome fundamental material and strategic disadvantages of the magnitude Germany faced. German pilots who flew captured Mustangs gained valuable knowledge about aircraft characteristics and optimal tactics. But That hard-won knowledge primarily confirmed what many already suspected or understood. Allied aircraft possessed significant and decisive performance advantages that German industry and engineering could not match during the war's final years given resource constraints and strategic circumstances. The experience of German test pilots confronting the Mustang's capabilities and coming to terms with American engineering achievement parallels the broader German military experience during World War II's latter stages. Across all theaters and services, initial confidence in German technological superiority and tactical innovation gradually gave way to recognition that Allied forces possessed decisive advantages in multiple critical areas. Vast industrial capacity, access to strategic resources, enormous manpower reserves, and increasingly sophisticated technological capabilities that matched or exceeded German achievements. The Mustang represented one particularly visible manifestation of these Allied advantages. American designers had created an aircraft that excelled at its intended strategic mission of long-range bomber escort. American industry produced it in enormous numbers with consistent quality. Despite the design's complexity, American training programs prepared pilots thoroughly to extract maximum performance from the aircraft in combat. German forces could study, analyze, and appreciate these advantages through programs like the Wunder Circus Rosarius without being able to replicate or effectively counter them given the strategic and material constraints they faced. The technical sophistication of the P-51 challenged and ultimately demolished German assumptions about American engineering capabilities that had been carefully cultivated by propaganda. Official information had portrayed Americans as capable of producing simple, rugged equipment in vast quantities, but fundamentally incapable of sophisticated design, requiring engineering excellence. The Mustang demonstrated conclusively that American engineers could create highly refined, efficient designs that matched or exceeded German capabilities in the areas that mattered strategically. The wing design represented advanced aerodynamic research successfully implemented in high-volume production. The Packard Fe 1650-3 Merlin engine demonstrated American capability to manufacture complex high-performance engines in large quantities with consistent quality. The aircraft systems integration reflected sophisticated engineering that successfully balanced multiple competing requirements to create a coherent, effective weapon system optimized for its intended mission. German pilots who flew the Mustang extensively could not honestly dismiss American engineering as crude or unsophisticated based on propaganda. They experienced firsthand an aircraft that handled beautifully across its flight envelope, performed superbly in the mission profile that mattered strategically, and demonstrated thoughtful, competent design throughout every system. This direct experience forced acknowledgement that American technical capabilities exceeded German preconceptions significantly, with implications extending well beyond aircraft design to broader questions about relative national capabilities in industrial production, technical education, and engineering sophistication. The strategic air campaign over Germany succeeded in large part specifically because of the P-51 Mustang's unique combination of capabilities that other aircraft could not match. Long-range bomber escort deep into Germany remained operationally infeasible until the Mustang arrived in substantial quantities during early 1944 and began flying operational missions. Previous Allied escort fighters like the Republic P-47 Thunderbolt and Lockheed P-38 Lightning, despite their considerable capabilities in other areas, possessed insufficient range to accompany heavy bombers throughout complete missions to targets deep inside Germany and back to bases in England. This critical limitation allowed German fighters to simply wait until escorts reached their fuel limits and turned back toward their bases before attacking bomber formations during the most dangerous portions of their missions. The result was unsustainable bomber losses that forced suspension of deep penetration raids. The Mustang fundamentally transformed bomber escort operations by providing continuous effective fighter coverage throughout entire missions regardless of target distance. German fighters could no longer find extended periods when bombers flew without protective escorts. This operational reality forced German pilots to engage American fighters directly rather than simply attacking bombers, dramatically increasing the risk German pilots faced on every interception mission. Combined with growing Allied numerical superiority and declining German pilot quality due to training time reductions, Mustang escorts made bomber operations over Germany operationally sustainable for the Allies, while German attempts at interception became increasingly costly, ineffective, and ultimately futile. The Luftwaffe conducted extensive technical evaluation of captured P-51s at multiple facilities, with particularly detailed performance testing occurring at Göttingen, where German engineers created comprehensive technical reports documenting Mustang capabilities in systematic detail. These evaluations measured speed at various altitudes, climb rate throughout the altitude range, absolute ceiling range under various configurations, and handling characteristics across the complete performance envelope under controlled test conditions. German engineers created detailed technical reports documenting all findings, comparing P-51 performance directly with German fighter types under equivalent conditions and analyzing specific design features that contributed to observed performance. These technical reports circulated within German aviation circles, informing aircraft designers about Allied technical approaches, providing tactical planners with accurate performance data for operational planning, and giving operational commanders realistic assessments of Allied capabilities for use in tactical decision-making. The reports confirmed what combat pilots had been reporting from actual engagements. The Mustang possessed significant and decisive performance advantages in the most critical categories for the strategic mission of bomber escort. The systematic analysis highlighted the aircraft's exceptional range that enabled strategic escort missions, superior high-altitude performance enabled by the two-stage supercharged engine, high maximum speed that provided tactical flexibility, and harmonious handling characteristics that reduced pilot workload and enabled effective combat maneuvering. German engineers noted and documented specific design features that contributed to these capabilities, including the aerodynamically efficient wing design, the powerful and sophisticated supercharged engine installation, the large internal fuel capacity supplemented by external tanks, and the thoughtful systems integration throughout the aircraft. The technical intelligence gathered supported conclusions that existing German fighter designs required substantial improvements to remain competitive with current Allied types, much less future developments that would certainly incorporate lessons learned from current operations. Germany initiated several ambitious fighter development programs during 1944, specifically intended to counter Allied air superiority through advanced technology, including the Focke-Wulf Fw-190D with inline engine for improved high-altitude performance, the Focke-Tar 152 specialized high-altitude fighter, and various revolutionary jet and rocket-powered designs. These programs reflected clear recognition among German designers and military leaders that existing German fighters like the Bf-109G and Fw-190A could not effectively counter advanced Allied aircraft like the P-51 Mustang given the performance gaps in critical areas. However, severe material shortages, production delays caused by Allied bombing and resource constraints, and the rapidly deteriorating overall war situation prevented these advanced designs from entering operational service in numbers sufficient to influence strategic outcomes or reverse Allied air superiority. The jet-powered Messerschmitt M262 represented Germany's most successful attempt to leapfrog Allied piston engine fighter performance through revolutionary turbojet technology. The Me-262 possessed substantial speed and firepower advantages that made it extremely deadly against Allied bombers when flown by skilled pilots who understood how to exploit its capabilities. However, the type suffered from chronic engine reliability problems that limited operational availability, required extensive concrete runways that were vulnerable to Allied attack, consumed vast quantities of increasingly scarce aviation fuel, and arrived too late in far too small numbers to alter strategic outcomes or seriously threaten Allied air supremacy. Even the Mi-262's impressive technological advantages proved strategically insufficient to overcome overwhelming Allied numerical superiority and the Luftwaffe's collapsing infrastructure, fuel, supplies, and pilot training programs. The closing year of World War II in Europe saw the Luftwaffe's gradual collapse as an effective combat organization capable of offering meaningful resistance. Massive pilot casualties, critical and worsening fuel shortages, manufacturing disruptions caused by Allied bombing, and overwhelming Allied numerical dominance combined to render German air defenses increasingly impotent. Regardless of individual aviator skill or bravery, the captured aircraft evaluation program continued functioning for as long as circumstances allowed, striving to produce tactical intelligence that might enhance German pilot survival prospects, even as the strategic outcome became unavoidable, and final defeat loomed. German airmen who had flown captured Mustangs, extensively and comprehended Allied aircraft performance faced the war's conclusion with complex, often conflicted emotions. Professional flyers respected the technical brilliance embodied by aircraft like the P-51, even while lamenting their role on the losing side of history's most catastrophic conflict. Many entertained no illusions about Germany's downfall being anything other than complete and unconditional. Having observed firsthand the overwhelming material superiority Allied forces possessed in every aspect of military power, the captured Mustang evaluation effort remains a compelling and illuminating episode in World War II aviation history, showing how professional military institutions seek to understand and counter enemy advantages through systematic intelligence collection even in desperate situations. The program furnished operationally useful knowledge to German pilots through direct familiarity with Allied aircraft. Yet this understanding ultimately could not offset the profound disparities in industrial output, resource access, technological sophistication, and trained manpower that defined the air conflict of 1944 to 1945. German aviators fought with notable bravery, impressive tactical acumen, and professional expertise, but faced adversaries with greater resources, superior machines, more comprehensive training, and a strategic posture that proved decisive. The admission by German test pilots that they had never encountered flight characteristics like those exhibited by the Mustang represented professional respect for American engineering accomplishment and an honest recognition of the substantial performance disadvantages German airmen confronted in combat. This recognition, forced by first-hand experience rather than propaganda or indirect intelligence, demonstrated that confronting unpleasant truths often requires direct personal engagement that cannot be dismissed or rationalized through ideology or wishful belief. The legacy of the Wanderzirkus Rosarius and related initiatives extends well beyond their short-term tactical value, underscoring the importance of systematic intelligence work, technical proficiency in evaluation, and frank appraisal of enemy strengths, even under the harshest strategic conditions.